Sorry, I forgot to record. Please, this is just an advice. If you can check, we have been receiving exam timetables. I think you have more than one. If you check your emails, I will advise you, please, can you please check the latest one, because some of the dates changed. They kept on changing. So please make sure that you have the final timetable with the correct dates. And also confirm with your friends if whatever you saw from the timetable is what they're saying. Because in most cases, students, they miss exams. When you're checking it there, you think the exam is at 2 o'clock. And you find that you missed it. The exam is not at 2, it's at 8:30. So please, you know your modules. Just make your own summary on when are you writing a certain module. You can have a piece of paper, and then you summarize your timetable, even the time slot. You can stick it somewhere, or you can store it from your phone, so that you don't miss the time, the test of the time of the exam. So without a waste of time, let me open my section. The test that was written on Saturday. I'm not going to take a lot of time explaining there. As I've indicated, we have a lot to cover today, so every minute count. So we're busy marking your assignment. It seems like you guys, whenever you were writing that assignment, you were in a hurry. You decided not to interpret a lot of things from that output, which we even called your class rep to get an understanding what was the problem. But she also failed to answer our question, that what was the problem. I'm looking for that test that you wrote on Saturday. SSTB. I'm failing to locate that paper. But if you have it with you, I have the printed one here, but it was going to be easy when it's projected, but I'm failing to locate that paper. But it's fine. When I get it, I'll branch. Let me not focus on the notes. Immediately when I get it, I'll branch to that paper. So some of the things that I'll be covering today is the things that we have done with Mr. Chabalala when dealing with chapter 2. He explained on how to check for outliers. He explained on how to check for the assumptions, the assumptions of the model. So I'll be covering some of those things. And again, when he explained how to check for influential observations using the leverage procedure, It is also possible in matrix in multiple linear regression to do that. But now, instead of um, using that formula that you used, that which says 1 over n, we'll be using the head matrix. You know what is a head matrix? Because this question was even there in your test. The head matrix I'm referring to H, but I prepared the notes for you here. So let me share the notes. Um, um, can you see the projected slide? Guys, can you hear me?
Yes, we can see them.
Thank you. So when you were dealing with simple linear regression under the leadership of Mr. Chabalala, you used a certain formula to check if an observation is an outlier or not, comparing it with 2H bar. I assume you're not seeing this part for the first time. Um, why I'm so certain about this? Because some of you, even on the assignment, you are using this formula to show that you are not seeing this information for the first time. So I don't know, Mr. Chabala, which formula did you use to check for influential observations? I'm not sure if you used the one from my slide, because we have different formulas. So I didn't check with him. I'm not sure if you used this one. I'm not sure if you used this formula to check for influential observations. Um, but it doesn't matter. So in matrix notation, it is also possible to apply leverage procedure to check for influential observations. Except the leverage procedure, can someone give me other two methods that can be used to check for um, uh, influential observations? What are the other two methods that can be used to check for influential observations that you know of?
Jackknife and cookies distance.
Jackknife and Cook's distance. True. But due to time, we won't be able to use the other two methods, um, the jackknife and Cook's distance, due to time, because we're left with only tomorrow to conclude whatever is whatever part is remaining. So um, the part that we have to understand is the what is the leverage procedure is fine. The other ones just know how to apply them. But this one, make sure that you know how to use it, the leverage procedure. So I'll explain it in the form of matrix notation, because this one here is when you are doing it what under simple linear regression. I indicated here when you're having only one independent variable, it's fine. You can use this formula. This formula is quick. But when you're using multiple linear regression where you have more than one independent variables, now you must bring in the head matrix. Um, you This formula, the head matrix formula, is also applicable even when we are dealing with simple linear regression. But the good thing about simple linear regression is quicker when you are using this formula, the one that is projected here, when dealing with simple linear regression. But when you're dealing with multiple linear regression, now we have to move to what? We have to move to the head matrix. Sometimes it's called the projection matrix. The projection matrix. So you are not seeing this formula for the first time. You are not seeing this head matrix for the first time, this formula here, or projection matrix, it doesn't matter. Sometimes some other textbooks, they will use P, some they will use H. H, they call it head matrix. Sometimes they will use P. When P is used now, we call it projection matrix, but it's the same thing. So when we're using the head matrix, the values that you'll be interested in is the values on the diagonal line, the values on the diagonal line of that matrix. If you're having 20 observations from a data set, it means your matrix will have um, values on the diagonal lines. There will be 20 diagonal line, this line here, the one that, if you can check from this matrix, the diagonal line where I wrote H11, H22 up to HII. H11, it means that value correspond with what? With the first row, the first variable, the first information from what? From your data set. H22 is in line with the second information from your data set. If you're having 20 observations from a data set, it means H2020 will be in line with what? With the last values from what? Or observations from your data set. So to check which value is an outlier, you will be guided by what? By this matrix here. So to check which variable is influential, you'll be using the head matrix. But in your case, I won't ask you to calculate or to find this matrix. I cannot ask you to find this matrix because it will take a lot of time. But I can give you the matrix and ask you to check which observations are influential, or to check if we have any values which are influential in our data set. I can give you a 10 by 10 matrix, a 15 by 15 matrix, and I ask you to tell me if we're having influential observations in our data set. So it means what you only need is what? Is to know how to calculate 2H bar. 2H bar, the definition is still the same. Is the number of parameters in from your model. Remember, when you count the parameters, don't exclude beta zero. Beta zero is also a parameter. So count the number of parameters from a data set and divide by what? Divide by n. Um, this method is applicable when p is less than n. When p is less than n, the formula is applicable. When p is less than n. Imagine if your parameters, you have 20, but your n is what? Is 10. So there will have a problem. But that one is a special case. Just know that in most cases, number of parameters are less than the sample size. So this one I will give you in the form of a tutorial. You will do it. I gave some other guys a special test on Monday, and I asked them to prove to me that the head matrix is symmetric and what? I dependent. I asked them to show me that the head matrix or the projection matrix is what? Symmetric, and also what? And also I-dependent. How do you prove that something is symmetric? How do you prove that something is symmetric? When you when you want to find the transpose of that matrix, you'll get what? The same thing. If you transpose the head matrix, you'll find what? You'll find the head matrix. So it's a proof that what is symmetric. Two, I asked them to prove that the matrix, the head matrix is I-dependent. What was the what did I mean by that? It means that when you multiply the matrix H with itself, you will get what? You will get H. So h by h, you'll get h. Same applies to, if you multiply h by h by h, you'll get what? You will get h. So when you're asked to check if something is idempotent, simply saying if you multiply that matrix with itself, you will get the same matrix. So when you have these notes, go through them. So again, let's prove this one. I don't want you to see the other part. This one here, by saying y hat is equal to hy, prove that. These things, guys, they're not that difficult. You just need our attention. How do we prove that? We know that y hat is given by x beta, xb, which is equal to what? Yes? I'm listening. I thought this end. So when would I hope my class reps are here. You know that the other part is given by, when we change bit, it will be what? Prime x inverse to the power negative 1 y. I'm almost done. You know that one is the case. Xy, x prime y. If you check this part is what? This part is h. If you check that part there, sorry. If you want to say something, please say it out. That part there is h. So it's h. Class rep, the reason why I called you is because of what? You can check your attendance there, that your people are not here. We are not sure that is it because they noticed that they
Sir,
will be
I don't think
pointing
that
to.
last rep can hear you because she's even asking in the chat box, or is Sir talking or it's my network? I think she has some network problem.
Thank you, leadership. Yes, so I was saying the reason why I called here is because it seems like people now decided to go a different direction, because we agree that our focus is to get to the promised land. Maybe they've noticed that to get there it's not that easy. Maybe they decided to uh, go back, because if you know that you are in a situation, you are supposed to be here. So if only 60 are attending, it means only 60 students, they take this class serious. So if you can check, guys, whenever I set a test, the proofs, there's no way that I can keep on repeating something that we have done in class. It means what is needed from you, don't memorize these proofs. Understand the background of how to go about these proofs. I can give you any proof now. I say prove this. Does it mean that because I only did 4 to 5 proofs in class, means I can only bring those ones? No. As long as I've done it in class, even if I didn't do it in class, as long as I know you have an idea on how to deal with matrix approach, I can bring any proof. Like in the exam, there's no way that you won't find the proofs. So you have to do your part, guys. So let's continue. Um, the next part now. So there's that proof there. I did it for you. So there's this part here. You guys, you are ignoring this part from the assignment. You are ignoring this part from the assignment, which is, I don't know what could be the reason why you are not explaining that this part. Leverage, there's what we call leverage, there's what we call influential, and we have what we call what? An outlier. These three things are what? Are not the same. These three things are not the same. Let me give you, I want the statement is either true or false. Whatever I'm going to say is true or false. An observation can be an outlier but not influential. True or false? An observation can be an outlier but not influential.
True.
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 True. True.
An observation can be influential and can be an outlier.
True.
True.
What is the last option? An observation can be an outlier but not influential.
That is also true.
So you must understand that, because why am I saying this? Because when you're busy interpreting the assignment, you will indicate that I have a value which looks like an outlier, but you guys, you are not checking if it is influential or not. You just tell us that we have an outlier, but you are not done. Is it influential? Are we supposed to worry about that outlier? You guys will just keep quiet. So that is why we think we maybe didn't have enough time to do the assignment, because there was a time where we even thought of asking you to resubmit again, go and do the right thing and submit. So this notes here, they will help you on how to solve to answer some of the questions. I will share this document with you. So not all outliers are influential. That's something that you have to get. So this is the what? This is the you can use these notes. You will go through the notes, and then they will tell you the difference between uh, these uh, types of outliers. Like for example, if you check the first one, there are no outliers here, isn't it? Example 1. But when we move to example 2, we have an outlier there. We have an outlier there. But now we can see that that's an outlier. But is it influential? You see? Is it influential? You have to check that. Now we have this one. What is the difference between these two outliers? Do you suspect this one is influential or not? This outlier. What are you suspecting? Can you say this is influential? We're just suspecting, but remember, you still have to prove it. Can we say this outlier is influential? Or
No.
What is the difference between these two outliers? Can we say this one is influential?
Sir,
Yes, I'm listening.
sir,
There's an
I don't know
outlier.
if I'm wrong, but I'm suspecting that is it the first diagram?
Yes,
No, the second one.
this one.
Yes, I don't know. I suspect that it's influential because you can see that data point, it has the power to change the direction of the slope.
Thank you very much,
So for me, I
leadership.
suspect that it's influential. And then the other one,
I want to thank you because you are right. This point here, it can have an influence on the direction of our slope. But if we check the second one is an outlier, but it's in line with what? With the data points. So this one, even if when you draw a regression line, obviously there's no way that it can change what the direction of the what of the slope. But when you check this one can be influential. So this one we suspect it can be influential because of what? Where it is placed. But this one, the other one here, is on the direction of what? Of the other observations. So but then this file will help you to do what? To do so here's the last one. Do you think the following data set contains any outlier or any high leverage data points? There's a question there. Let's look at this one. We have a red dot here. You see, this one is even worse. Now we're talking about what? A high leverage point. We're worried about this point here, where y is 13 and then I think x is what? Is maybe 12. We suspect that here we have what? A high leverage point. So I will share the what? These notes. So these other two methods, the remaining two methods about which can be used to check for influential observations, you don't have to worry on how do we do the calculations and so forth. What you have to know is that how to define them. How to define them. I repeat, deleted residuals or jackknife, you must know how to define it. Same applies to jackknife. You must know how to define jackknife. But the application part of it, you don't have to worry about it. The only one that we have to know is what? Is the leverage procedure when using what? When using matrix notation. So if you can check, whatever I'm teaching today is something that we have done with Mete Chabalala. So the next one that we have to cover is let me take it to the next page. Is the Ben-Westin test. Where can we use the Ben-Westin test? Where can we use this test? Guys, talk to me.
Test for correlation.
Test for correlation. So now, if you can check, you have done this with Metachawalal. So it's just the repetition. So why am I doing this part? Is because it's also applicable when dealing with what? When dealing with multiple linear regression. It's also applicable. So we're just recapping because it's something that we have done with Mr. Chabalala. So I have a question that was there um, Mr. Chabalala's test, um, special test, which was returned, I think, is Monday, which is directed to what? To the Ben-Westin. So those who wrote the test, so you know how to apply the Ben-Westin test. What is the first thing that you have to do, guys? You are testing, assuming that you are testing for positive correlation. So what you are supposed to do first is to find what? Is to find the predicted values, isn't it? The first thing that we have to find is the predicted values. So from that test, they were given this information. They were given this information together with the y values and the predicted y values. The predicted y values are here. So can you please find the errors? Please find the errors for that data set. Calculate the errors. You don't even need a calculator to calculate for these errors. So please, I'm giving you 2 minutes to find the errors and also to do the differencing. You know how to do the differencing, right? I assume you have done this with Mr. Masongani when you are transforming the data set, when you apply the first differencing. Even on this one, I need the errors and then also do the differencing. So the procedure for simple linear regression is the same as for multiple linear regression. When you find the differencing, you know the formula, isn't it? It's the numerator of what? Of the formula for the Benoit stem. You see that numerator there? The numerator. So you are not seeing these things for the first time, guys. So can you please find those differences? At first, I said find the errors. The second one, find the differencing. You know that when you apply differencing, the first part there won't have anything, isn't it? So please complete this table here. Complete this table. Find the errors. You know how to find the error, guys. It's yi minus yi hat. The second step, find the differencing. You know this cell, I think this cell will be empty. So it means you need the values for the other cells. Please, guys, do that task. I'm giving you, we're no longer having a break in do it until quarter past. Find the errors and the differencing. From there, we'll move. Find the errors there and the differencing. I'm giving you until quarter past to do that. So as I've indicated, if you can check, it doesn't matter if you're given a simple linear regression problem or a multiple linear regression problem. The procedure is the same. The procedure is what? Is the same. Let me know when you are done. Guys, can you hear me? Seems like today you guys, you are angry. Guys, can you hear me?
Yes.
Yeah, let's work, guys. Let me know when you are done. Guys, are you still there?
Yeah.
How far?
Yeah.
How far, guys? Can you give me the errors? What is the first error there?
It's 2.8.
Is it positive, negative?
2.8.
2.8. Yes. I'm listening. Let's continue.
Negative 0.8.
Yes. Let's go, guys. I'm not sure if I'm receiving the information.
Negative 2.7.
2.7.
Yes, let's go. The next one. Guys, the
1.3.
time I said, sorry,
1.3.
1.3. The time I said do the problem, you didn't hear me.
Negative 2.6.
Yes.
Three point four.
Okay.
One point five.
1.5.
Okay, let's go.
Minus 0.5.
Minus 0.5.
Yes.
1.6.
The last one.
Negative
Minus 2.4.
So what is sum of errors squared? Square the errors.
So before we go to that, the first one on the errors is 1.2.
Which one?
The first one on the errors.
This one.
The other one is 2.8 is 1.2.
Which one, sir? Which
Yeah,
column?
two. The first column.
This one is supposed to be what?
The one 1,2.
1,2.
Yeah.
How did you get 1,2, sir?
Mhm.
Yeah, you are right. I think you are right. It's fine.
Yeah.
Square the errors, guys. What are you getting? 1.2 squared plus 1 - 1.8 squared plus -2.7 squared. What are you getting? Before you find the differencing, can you please square those errors? 1.2 squared plus -0,8 squared up to -2.4 squared, provided all the values are correct. What is the answer?
It's 40.2.
40.2.
Yeah.
So if it's 40.2, do you notice something there? Do you notice something there? 40.2. Let's go to when you square the errors. This is very, very important, guys. Let's check this. When you square the errors, you will get what? 40.2. I decided to run the ANOVA table for you. So it means when you square the errors, you are finding what? Do you see it? Do you see this one, guys? So when it's the denominator, from your formula is SSE, the denominator. So this is the same in matrix notation. This was same as what? As E prime E. This is in matrix notation. In matrix notation. Matrix notation is E prime E. Remember, E prime E is the same as what? Which is equal to, that is why if you check my formula, what I've done, let's check my formula here. Oh, sorry for that. You see my formula, what I've done. I asked you to square the errors. And from there, I also indicated that whatever you're doing in matrix notation is the same as E prime E, which is E prime E is the same as what? As SSE. So if you're given the ANOVA table to do some calculations, you must know that the denominator, you have it. You don't have to go and square those errors again. You have it by what? You just go to that ANOVA table and pick out what? And pick what? The SSE. Just pick out what? The SSE is what? Is your denominator. The numerator, you have to do what? Do the differencing. So continue with the problem, guys. Find the differencing. Mr. Chavala taught you how to find the difference. He taught you this thing of how do you find the differencing. I gave you a clue there that the first cell will be empty. Get the other ones, guys. Write them down, guys. These things of when I ask you to do something and then you wait for me to come back, it's not right. Do the what? Find the differencing there. Sorry. When you want to find the differencing now, you need what? You need what? The errors only. If you can check, we're not using the X values. We're only using what? The Y values. So what is the first differencing? Leaders, what is the first differencing?
-2.
No, it's fine. It seems like you guys you decided otherwise. Let me continue. So you'll find that the first difference. So in matrix notation, remember
Oh, say,
yes, you're saying? Are you saying something?
Say,
Okay, so let me continue then.
say,
Yes,
say. When we
I'm
find the
listening.
difference, when we find the differencing, do we say like et minus 1? Do we also square it
Yes,
the
the
same?
same procedure as what we did with Mr. Chabalala.
We square
The
it.
numerator, check the numerator there. Check the numerator from my formula.
Okay.
Sorry. Sorry about I used I, but you can use T, still fine. But this is not a new thing, guys. Guys, this is something that we have done with Mr. Chabalala. It's not something new. So
So there's no
uh,
difference when
there's no
applying.
difference. There's no difference. There is the formula. ET, Mr. Chabala was using ET. I used AI, it's not a problem. You can use ET. ET minus ET minus 1. ET minus 1 all
The
squared.
difference
The
part is
procedure is
that
still the same. Yes?
the differencing part is that numerator there.
Yeah, it's the numerator. Remember, we're trying to find the numerator, isn't it, leadership?
Okay, leadership. I understand.
Yes, but it's fine. You can do it the way you're doing with Mr. Chavala. With Mr. Chavala, if mine, the procedure that I'm using is the long one, the procedure is still the same. The only difference is what? Is that now we're in multiple linear regression. But finding the errors, the formula for finding the errors didn't change, isn't it, leadership? The formula for finding the errors, it didn't change. I was just trying to indicate that even in multiple linear regression, we have a section where we can test for what? For autocorrelation. So when going to the exam, you must also know how to check for autocorrelation, both in simple linear regression and in multiple linear regression. I can bring this type of equation from my section. Mr. I can bring this type of equation from his section. So you must know how to apply this um, uh, uh, procedure from both sections. What I was trying to emphasize that if you are given an ANOVA table, you should not worry much about what? Should not worry much about the denominator. If the denominator, why? Because if you're given the ANOVA table, you just go and pick the SSE, which is the denominator. If you're given the ANOVA table, it means for this formula, already what? You have the denominator. What is left is to find what? The numerator, the upper part. The lower part, if you are given SSE, just plug that SSE as a what? As your denominator. So how do you check? What do you do with this information? This, whatever you're doing here, you're doing the test statistics. So how do you conclude? We are saying if D, the calculated the Ben-Weston value, if it's less than DL, DL is now here we're talking about the values from the table. The the lower limit, DL represent the lower limit from the Ben-Weston table, and U represent the upper limit from that the Benoist table. So what is going to happen is that you are going to pick two values from what? From the table. So your n will be the sample size. N will be the sample size of the given problem. Like in our case, what is our sample size? What is our sample size from the given problem? How many values do we have? Let me go up. Help me to count. How many values do we have?
I think it's 10.
We have 10, right?
Yeah.
Yes, so it means you have 10. How many parameters excluding beta 0? How many parameters? Or you can simply say, how many independent variables do I have? How many independent variables do we have here?
9.
Independent variables can't be 9.
Oh,
Independent variables, guys.
Isn't it 1?
It's 1. Yes. As you forgot these things. You guys. I'm trying to get the Benoist table that I show you how to apply it. So you have 1 and what? 1 and 10. And then you are going to compare. So this is how we use the table. I'm trying to again locate the table, the Benoist table here. I was checking the wrong place. So I just want to share with the table, the Benoist table, with you so that you. So we have different types of the Benoist table. We have different types of tables, the Benoist table, like what we have with the what? With the theta, with the F test. F test, you can have 5% table, 1%, 0.1, 2.5%. Same applies to the Benoist test. We have those tables. So let me stop sharing this one. I want to, so you said we are going to check for 1 and what? We're going to check for 1 and 10. Can you see the one that I just shared now? The table. So what I'm saying is that when talking about the Benoist test, let's check this one. You see this one is a what? It's 1% point. But what I'm interested in now is to explain how to check the value from the table. So we agree that our K is 1. So we are going to check for this 1 and what? And 10. We said it's 1 and 10, right? So it means the value, suppose our percent is 1%. It means that our values for interest is what? The lower limit, it will be negative, it will be 0.604 and 1.001. Remember, I'm saying provided we're using what? We're testing using 1%. If we move to the table of 5%, means it's a different thing. So when we're using 1%, that's how you check the value from what? From the Benoist table. We have to collect the two values. Like in our case, we said our K is 1 because we have only one independent variable. Or you can simply count what? The number of parameters excluding beta 0, which is still what? Is 1. So since we are testing for positive autocorrelation, you don't divide your alpha by 2 because you are testing for one-sided test, isn't it? So one-sided test, we're testing if we're not having a positive correlation. So it means your alternative hypothesis to say P greater than 0. So we'll use the percent the way it is as 1%. So if we move to 5% table, it means even the values will do what? Even the values will change. But that one, it doesn't matter. What matters is as long as you know how to use what? You know how to use the table. So we agree that if your p-value, this theory is there. Where's that document? So I will share this document with you guys. My class rep should help me. I will work with your class rep. She must remind me to put these notes on Blackboard. I wanted to make sure that I do the feedback for the test. That Mr. Chabalala will do the what? Is in the afternoon. So suppose now you have those two values. If your the Benoit-Stinn value, the calculated one, is less than the lower the value from that you found from the table, the lower limit one, you reject the null hypothesis and conclude that there is what? There is a positive autocorrelation. If your calculated value, this now is option number 2, is greater than the upper limit, which is the 1.001 from that table, it means you fail to reject the null hypothesis and you conclude that there is what? There is no positive autocorrelation. Now, if the value, the calculated value, is between the two values that you collected from the table, it means the test is inconclusive. So the process is the same as simple linear regression. I just had to bring in this part so that you do what? So that you can see on how to apply it when dealing with multiple linear regression. Same applies to which one is this one? Lack of fit test. Lack of fit test, I won't ask you to perform lack of fit under multiple linear regression, but I can give you an output and ask you to test. The testing part is the same as simple linear regression, but the calculation part is time consuming. So I cannot ask you to test for lack of fit under multiple linear regression to find those ANOVA tables and all those things. But I can give you what? The ANOVA table and ask you to do the hypothesis testing. But calculating the ANOVA table, no, you do not worry about that part. So,
Say,
yes.
how do you write the null hypothesis for this the Benoit-Stinn? Are you doing the same way as the simple linear regression?
Yes, it is here. Remember, the only difference, that's why I said, in fact, there's no difference. It's just what will change is the number of parameters in it, because in multiple we can have more than. Yeah, it is leadership. I wrote it here.
Okay, okay. Thank you, sir. Thank you.
Yeah, since I said I will share the thing, these notes with you guys, you'll be able to go through the pamphlet, and whatever you don't understand, you can feel free. You can ask.
So,
As I was, yes.
say, let's say for in case we perform the log of fit and we conclude that the data we conclude that the model does not fit the data well. What do we perform to that data to make it like for the model to fit?
You're breaking. Can you please go closer to the mic?
I'm saying, let's say we perform the log of fit and we
Yes.
conclude that the model does not fit the data well. What can we
Yes.
do to that data for the model to fit the data well?
Transformation.
Okay.
Remember the transformation. I think Mr. Maswangani, when he was teaching you how to transform the data set, he spoke about the square root method the differencing, reciprocal method. You remember those things that Mr. Masongani was telling you?
Yes.
I know he told you about how do you transform the data set. You can go back to the y variable and you take the square root of all the values. You transform the data set, or you take the natural logarithm. You take the log of all the values and run the data set again.
Okay.
Yes. Or what I'm saying concerning time series, am I wrong? There was no part where Mr. Masongani told you on how to transform the data set.
You are right, sir.
Yes.
You are right.
So
That's how-
I know I was not in that class, but I know there's no way that you can do time series and then you don't talk about transforming the data set. So even here, when you have those challenges, you have to transform the data set. The same applies to leadership. If instead of running the results for you, if we asked you to go and run the results yourself, and you find that there's a lack of fit, it means you must make a plan to solve the issue of lack of fit by taking the natural logarithm. If you can check some examples from the books that we are using, you will see that they are transforming the data set if some of the assumptions are violated. Because what is the it's not advisable for one to use um, a model which doesn't where some of the assumptions are violated, like what was happening in the assignment. You said you have outliers. That's what you're reporting to us. You said, from my data set, I noticed that I have an outlier, which means you must first check if that outlier is influential. If it is influential, you cannot use the model for what? For doing the predictions. Because you have an outlier which will mislead what? Which will mislead the public. So if you have that outlier and it's influential, it's influencing our data set, uh, as what the reviewer said, he said it can make our beta to be what? Negative, while in reality supposed to be what? It's supposed to be positive. So before you can make any predictions, you must make sure that all your what? All your all the model assumptions are what? Are not violated. Because if you continue with a model where some of the variable assumptions are violated, it will create a serious problem. So there's an example of a lack of fit here. As I've indicated, I won't ask you, I won't give you a problem like this and say test for lack of fit. No. What I will do, I can give you what? I can give you the value. Sorry, I can give you the output and ask you to test. For example, if you can check this data set, let's stretch this data set to, let's apply the lack of fit uh, procedure. Let's check the first two, this one, the second row. We have 19 and 45. They get the value of what? The y value is what? Is 71. Again, we have 19 and what? And 45. They get the value, which value? 76. When can we apply when can we apply the lack of fit procedure? What is the definition of lack of fit?
When we have replicates.
Yeah, repeated observations, isn't it? So this is what is happening. If we can check here, y is 71, x1 is 19, x2 is 45. Again, y is 76. Now y is 76, but it's still claiming what? 19 and what? And 45. Same applies to the next row. Y is 63. Y is 63 is claiming what? 20 and 29 values. And again, Y again is 63. It's clear so far we don't have a problem because they said the values are the same. But now check 80 now. When Y is 80, it's still claiming what? 20 and 29. Even if we move to the same applies to the next row, Y is 80, Y is 80, and the independent variables, the observations is what? 21 and 93, but Y is 80. Y changed to 64, but still the values is what? 21 and 93. Y changed to 82, but the values is what? That's still 21, 93. The same applies to 66. So it means for this problem, we can check if we're not having a lack of fit in our data set. I can run this for you during the tutorials, and I can ask you to test if we have a log of fit or not. So the section that I was planning to cover today, which is I assume is the last section, is the nested models. Nested models is applicable where we have assuming that we have 5 independent variables from a given problem, but you decide to fit a model with only 2. So nested models, you have to check if is it not a mistake to leave the other 3 independent variables out. Let me repeat. Suppose we are given a problem with 5 independent variables, but the fitted model is having maybe only 3 independent variables. Remember, you have 5. So you have to check if the other 2, which are not included in the model, are not making a significant contribution in our model. Cannot make significant contribution if we include them in the model. Remember, this now, it takes us back to what? To partial F. But now we're using nested models. Now, what is going to happen is that, but we'll do this one in the afternoon. It's very, very important to know this section because it's part of what? Of the upcoming, the remaining assessments. I hope you understand the language there. It's part of the remaining assessments. So we'll do this one in the afternoon. Now I want to trace that test paper and give you the feedback. Yes, my brother?
Morning, sir.
Yes.
Yes, sir. My question is just for me asking on the practical part, sir, since
Yes.
we're almost done with this module.
Yes.
So I wanted to know on when are we going to attend the practicals since our computers are ready for us to use. I
Yes.
saw such
Thank you very
program.
much.
I saw SAS installed in the first floor. Our computers
Yes.
in first floor that installed the SAS 9.4 is there, and R and SPSS is
Yes.
installed. So I wanted to know on how we're going to attend those classes since maybe from today we may find out we meet for the last time.
No, we're not meeting for the last time.
Or we're not meeting for the last time.
According to the agreement, we had an agreement that tomorrow to be used as what? For practicals. Even today afternoon. So what is going to happen is that you guys, you will go to the lab and then you open those So the issue now, I think it will be the what? The speakers. You cannot open. Are you allowed to put the headset there when you're
Yes,
attending
sir.
from
We
the
are
lab?
allowed. We are
You're
allowed.
allowed. Also, it's fine. So those who didn't install the packages, it's not a problem. You can simply go to what? You can simply go to the lab, go there with the headset, look for a PC which is having SAS or SPSS for in the afternoon session. Again, tomorrow we'll use that afternoon class as what? Practical session. From there, we conclude. Did I answer your question, leadership? Mashiane?
Yes, sir. I am answered, sir.
Yes. Today in the afternoon, we can agree. We will communicate with the class reps now that afternoon session, go to the labs. Those who manage to install the softwares, you can attend wherever you are. If you don't have a laptop and then you are far from the lab, try to go and attend with a friend. If you're having a friend, attend with your friend. Yes,
Okay, sir.
Manga?
Sir, I wanted to clarify this to the students. Now, every student, they told me here in Ahmed's building, they installed this software for me when we were starting with this module. And if you want the software, it's free here at our institution. They're going to download it for you and install every software you need in SaaS. They will give you all the packages of SaaS. So just go there with your laptop. They're going to help you if you don't want to use the PC here in our campus. Thank you.
Thank you very much. Smanga?
Sir,
Yes.
yeah, I heard you when you were starting, so you said something about the assignment.
Yes.
Yeah, so are you going to give us that assignment since you said most of the people didn't
No,
do what was needed?
we're almost done with uh, the corrections. We're almost done. No, we're
Uh,
just saying for future, because Sakari will still have some remaining assessments. But when you get that your report back, because we'll ask the person who submitted to come and collect what your report. You will see the what? You will see the what? The feedback there. We'll write the feedback. And I don't know. Let me open the speaker. The the camera so that I can show you what I'm talking about. So for each and every group, we'll write comments like this one. I'll come to you, Mr. Mashian. Um, I'm opening the video now so you can see what I'm talking about. Oh, sorry, I nearly opened the what? The oh, why is not sharing? Share video. Um, the videos.
Yeah, it's fine. We can see you. Sir.
You can you see the paper?
Yes.
Yes, sir.
You see the comments that are there.
Yeah, they are not that
Can you see
visible,
them?
but they can see.
No, it's fine. What I'm trying to say is that whenever you get your report back, we have indicated what you missed when interpreting the what the output. So all the documents that you gave us, you'll have what will be having comments there. So you should not worry about that one. So I hope I answered your question, Mr. Smang.
So, sir,
Yes.
the comments, like what you wrote there is the comments. Are they going to affect the marks? Are you detecting the marks relative to what you wrote with your red pen? They say.
Yes. Definitely correct, Leadership Manyam. Leadership Manyama.
Okay, sir.
Yes.
I wanted to ask Ugutim, as you said in the afternoon, we're gonna have practicals and tomorrow. Then that's
Yes.
all. There will be no more
Yes.
practicals.
Yes.
Okay, thank you.
But I agree we're still together in the second semester. Second semester, those will be doing second semester statistics. Those will be lecturing those modules. They are also going to do some practicals. Okay. Practicals will be doing them until.
Okay, so indirectly I can say we are done. Then we will not have any class
Yes, actually
from
today,
next week.
tomorrow is the last day of attending classes.
Okay, thank you.
Yes, thank you. Say thank you, leadership. Can you see the paper now? I just want to give you the feedback first concerning this Saturday paper, and I can also share the special one. These other guys, they wrote a special test on Monday. I can also share that paper with you. Let's check this one. I want to spend more time on things that I assume you know. Because what I've noticed with you guys, you are failing to answer the questions. You are failing to answer the questions, which takes me back to the quiz. It means I also have to give you the what, the answer for the quiz, the feedback for the quiz. I will ask Mr. Chabalala to come and give his what feedback for his quiz, optional quiz that you wrote, I think on Saturday, or is it Friday? Friday or Thursday, I'm not sure. And his optional test. I will ask him to join us in the afternoon to give you that feedback before we start with the practicals, because it's very, very important. You guys, you are losing marks unnecessarily. You just make some silly mistakes. So we don't want you guys to repeat this in what? In the exam. Mr. Class Rep Sillo, uh, sorry to say this, he's the one who performed better than everyone from this test. Sorry, I didn't ask him if he can allow me to reveal this information. Uh, I was supposed to consult with him if he mind for me sharing that he was the highest from this test. And the marks that he lost, I had to explain. I had to explain why he lost those marks. The marks that he lost, it was only from A, but the other questions he was he was getting them right. So I said, state whether the following statements are true or false and justify your answer. When using backward elimination method, it is necessary to specify the significant level for entry and a significant level for stay. The answer here is false. The correct statement supposed to say backward elimination method is necessary. For backward elimination method, it is necessary to specify the significant level for stay, because, so the because part from you guys was not there, because when dealing with backward elimination method, we don't need significant level for entry. Reason being, variables are entered, all the variables are entered in the module at once, isn't it? There's no condition needed for doing that. We only need the significant level for stay, because we'll be removing variables one at a time, isn't it? So you only need the alpha to remove, not the alpha to what? To enter. But you must give a reason why you are saying that. So you guys, you are not giving me the reason. You are saying false, we need significant level to stay. And you say full stop. Why? Why are you saying that? Justify your answer. Same applies to backward elimination method. When using forward elimination method, it is not necessary to specify the significant level for stay. The answer is true. Why? Because whenever the variable is entered in when applying backward elimination method, you are stuck with that variable. And why do we need you only need the significant level for what? For entry. If you want to justify with more than one one reason. But you must relate it with what? With the process that is applied when using that method. Except the VIF and the tolerance method, name any two indicators of multicollinearity. One of the leaders said correlation coefficient, and I marked the leader wrong. It's wrong. It's supposed to be correlation coefficient of the independent variables. Because when you say correlation coefficient of what? So you must be specific there. I marked the leader wrong because he said correlation coefficient or coefficient of determination. Of what? Because we can have coefficient of determination of the overall model. We can have the coefficient of determination of what? Of only the independent variables. So you must be specific what you're talking about, guys. So these reasons are there from the document. And C, this example, I tried to bring it because I gave you a task in one of our classes to go and do this problem. But from your notes, it's written as summation of yi squared hat is equal to that part there. So there was a common mistake here. This one I have to do it. These 3 marks, we see this, how many marks? Those are 3 marks, guys. But you guys, you decided to lose those marks. Let me connect this so that I can write. So you must understand the rules of the matrix. The rules of matrix. That's where you guys are still struggling. Because most of you guys, you didn't get those the full 8 marks. For those who collected the scripts, I managed to explain to them where they're getting it wrong. But if you didn't collect your script, please do so. Come and collect your script. Wherever you don't understand, we'll sit down, I will explain. So for those who got these proofs wrong, go and do them again and come and consult. You'll be preparing for what? You'll be preparing for the exam. So this one, D, suppose that we are given the following SAS output with 4 independent variables. This example, guys, this question is from your quiz, the quiz 2. Quiz 2, I just changed this part here. I just said to change this part. X1, X2, X3, X4. It was experience something here. SC. So I just changed this part, but the other, even what? Even this part here, I changed this one and these 2 values. Go and check that quiz 2. You'll see that is the same thing. So the first question that I asked, almost 99% of the class got this question wrong. 99%. For those who wrote section B, they didn't get Roman figure 1 correct. If we apply backward elimination method, where alpha is equal to 0, 1, which variable will be removed first? Give a reason for your answer. Can someone help me to answer this question? If we apply backward elimination method, where alpha is equal to 0, which variable will be removed first? In bracket, I said S there. Which variable? And in bracket, I put S. What is the answer for Roman figure 1?
1 or X3.
Sorry?
X1 or X3.
X1 or X3. I agree with the leader. Why are you saying or leadership?
I'm saying
Because
or
we cannot remove them at the same time.
at the same time. Only one variable can be removed at a time, and the
Thank
model
you
will
very much.
be.
He said or because he understands the definition of backward elimination method. So 99% of the leaders, when answering this question, they said X1 and X3 will be removed because they are having the highest P value and is the same. So when you say and, I was just circling that and then I pass. It is wrong when you say and. It means you are forgetting what? The definition. Roman figure 2. After removing the variable, this one is repeating, it was repeating, guys. After removing the variable, which other variable can be removed? You cannot tell, isn't it? You must first you must feed the model again, isn't it? You must feed the model again and check if you are still having insignificant variables. Roman figure 3, find the missing observations. This one, guys, again, even if you don't know these things, guys, you see this one is blank, it's empty here. But you can trace it using this one, isn't it? How did we get these two? How did we get these two? It means 27.66 divided by 13.68, you will get 2. So it means to get the t value here, you say what? Negative 0.13 divided by 0.4. You'll get the value. So this one, you just do what? You apply your mathematics, guys. You apply your mathematics. There was nothing difficult here. But I said, write the final model. When you are asked to write a final model, always you should focus on the variables which are what? You should focus on the variables which are significant. Variables which are significant. So when you write your final model, I was expecting your final model to have what? To have this one, this value, and this one. That's how you write what? That's how you write your final model. So I give you your 4 marks. B, I didn't have issues with B, except guys, you guys were still having some challenges with interpreting the coefficients, the slopes. Please make sure that you practice there. But most of you guys, you're getting this question right, except this one. Except the last question. You guys are still getting this question wrong. When you are asked to check for multicollinearity, you use the correlation coefficient of x1, x2. People were using this one here. They were using so no, not this one. You guys, you were saying SSR divided by SST. That one is the coefficient of determination. R squared. R squared, that R squared that we have from the ANOVA table is not the same as the R squared needed to answer this question. For this question, you need only the what? You need only the independent variables. You find the correlation coefficient between x1 and x2. So please, guys, don't make that mistake again in future. Don't make that mistake again in future, because you lost marks for. But the performance for those who wrote my section, those who were failing is because of they made some mistakes with some calculations. But most of the guys who wrote my section, they understood on what was happening. Those who wrote my section, most of them, I can say 90% of those who wrote my section, doesn't matter if they failed or what, but they were having an idea on what is happening. Even though some of them they failed because of what? Of mistakes when doing some calculations there. Now, this was the quiz now. You know what I've noticed? These things of saying working together we can do more. It killed you guys for this quiz. It killed you a lot because people were saying SSR is equal to y prime. Why? minus 1 over n y prime 1 1 prime y. SSR, guys, you know the formula. That is b is beta hat prime x prime y multiplied by what? Summation of summation of yi all squared over n. You know that part. But I don't know who gave you that formula, and then it seems like you trust that person too much. Because that person killed you guys. Immediately I see that the first part is not right. I was marking you wrong. Yes, Mr. Manyama?
Sir,
Yes.
we're having a problem, some of us, yes. Sir. So I want to
Yes.
understand from tomorrow, since the classes are dismissing, so can we find you in the office? So, cause
Yes, yes.
some of us will.
We'll communicate to the class rep on how will we do our consultations. We can even extend, because I agree won't be having some atlases. We can even agree that in a week maybe you can come. Those who want to see Mr. Chabalala, we can have an arrangement that come this day, or unless if you want us to come at the same day. But if those who want to consult concerning section A, sorry, simple regression, they must go to Mr. Chabalala. Those who want to consult about multiple part, they can come to me. But we'll be in the office, guys. We will
Okay,
be in the.
sir.
When are you writing our exam? When is our exam?
2nd June.
June. You said June, guys.
Yes.
Yeah.
2nd June.
Oh, it's fine. Okay, it's fine. Thank you. So now, for this question paper, my focus is not on what? It's not on. It's not on what? It's on the, not on the form on the proofs. I noticed that you guys, you don't know what you're doing. That's why I want to explain this part of the quiz. But in the afternoon, remember, guys, we agreed that I must first do the nested models. I don't need a lot of time to do that part. I'll just explain, but it forms part of the remaining assessments. You have to know it. So I will prepare some notes, and then I will take maybe 10 minutes or 15 minutes to talk about the nested models part, and then Mr. Chabalala will give his feedback for his test, and then we'll do the practicals. We'll use the second period to do the practicals. And then again, even tomorrow, we'll continue with the practicals. So the reason why I have to do the feedback for this quiz is I have noticed that you guys, you don't understand what we're doing. I asked you to test for the overall model.
Sir.
I asked, yes.
Sir, I would like you maybe sir, to help us to have this accuracy of writing, because some of us these things we understand too much, and when we do a silly mistake that is going to eliminate a lot of marks, is troubling with our mind. So please just help us with something. So how can we just see the accuracy as we are writing? How can we deal with the pressure, sir?
Yeah, we'll come to that one, Mr. Leadership. Like for now, can you allow me to finish this, because this one is some of the things when people talk about time, Mr. Manyaman, when people complain that time was not enough, sometimes it's not true. You are given how many minutes? 1 hour, right? You do this one. How many minutes do you need to do this one as regression?
2 or 3 minutes, sir.
Let's say 5. You have 1 hour. You have 45 minutes, right? Let's say 5 minutes. You are able to do this question, right? The second question, I asked you to test for using for the overall model. I gave you what? I gave you the F value, isn't it? You are given the F value, so it means you need what? The F tabulated, right? Isn't it, Mr. Manyam? You find the F tabulated. The F tabulated was greater than F calculated, which means you fail to reject the null hypothesis, isn't it? That there is a relationship between y and the two independent variables. Everyone was getting it right. Let me repeat. Everyone was getting this one right, was getting these 2 marks. Let's go to the next question. Is one of the two variables more useful than the other in predicting the candidate total mark? What is the answer? Let me write the answer. Perform an appropriate test. The answer is no. Because we failed to reject 0 from A. We get 8 marks. How many minutes do you need to write this statement? Manyama, are you still there?
Yes, I'm still here, sir.
How many minutes do you need to write this statement and get your 8 marks?
For writing that statement, only we need 1 minute, sir.
So, sir, what if you did that? You did the test using partial F test, and you found that you reject.
No, there's no way. Yeah. Well, let me explain. People, you know what you did, guys? They tried to apply the t-test. Some they applied partial F test. Some they used the confidence intervals. They tested for XY. They failed to reject the null hypothesis. They tested for X2. They failed to reject the null hypothesis. But you know what is fun? They forgot to answer my question. Because the answer here is what? Because my question is one of the two variables more useful than the other? That was my question. People didn't even answer my question. They were busy testing. It shows that you guys didn't understand what we are doing. Well, I told you guys, I said if we are testing for the overall mode, you fail to reject the null hypothesis. It means there is no need for you to do what? To do the t-test. What is the use for doing the t-test? You want to check which variables they given from the two independent variables, which variable is important in predicting y. It can be one of those independent variables, or it can be both of them, isn't it? But here now, already from A, you told me that these two independent variables are not helping me to predict what? To predict y. You already are telling me from A. You even said we failed to reject the null hypothesis and conclude that there is no linear relationship between y and the two independent variables. But when I get to B, I said which one is related to y. But after the question is saying which independent variable is related to y. You guys you decide to test. So that's why I noticed that it seems like you don't understand what you are doing. So it means, Mr. Leadership, he said you need 3 minutes, and I said let's may say 5 minutes. You needed 5 minutes to solve this problem. You need another 3 minutes to solve this one. 3 minutes to solve that because you have to go and check the value from the table and so forth. So 3 minutes, 5, 8 minutes. To write this, Mr. Manyama, I said you need 2 minutes. So now you use 10 minutes. To find the covariance of beta 1, beta 2. Yes.
Sir, do you see how
Yes.
you answer questions, sir? The way you
Yes.
answer questions is the way you want to answer. Sometimes you say, we are fighting with what the mind is telling us to do. We see you have tested, but you want to confirm by testing. This is what we are failing. Say,
Yeah. Yeah. Yeah, but what can we do, leadership? Let me continue. C, find the covariance of beta 1, beta 2. This one, you get it from the matrix of what? The answer for this question, you go to multiply the MSE with what? With the inverse. With the inverse. Go and check that matrix, the covariance matrix. Covariance matrix. Go to that one. Variance covariance matrix. covariance matrix. That's where you'll find the answer, guys. Go and check. Go and check that matrix. You'll find where it's written curve of B1, B2. And then I said 1 mark. 99% failed to get this question right. If the value of the coefficient of determination is 1, what will be the value of the residuals? This one, everyone was getting it, but I don't know if they understand what they were doing. So you see, to answer this question up to B, you said 10 minutes. To answer this question, I think maybe you'll need 2 minutes. To answer the last question, you'll need another 2 minutes, which is less than 15 minutes to solve the quiz. But you are given 45 minutes. Later on, you said the time was not enough. Which time to do what? I thank you.
Sir, you see, with
Say.
you, sir, the mindset you have, sir, we're going to be beast, sir. Just allow us to consume this knowledge you have, sir. Just give us the information, sir, when we come there, you know, for us to consult, sir. Hey, how you
I'll give
answer
you all the
questions,
information
I
that you're
see
looking
that
for.
we are not, we think we know. We don't know how to answer questions, sir. We know
You
the
don't know.
notion,
That's
but how
why,
to answer, no.
if I can be honest with you, if I was fair, Mr. Sidlo was supposed to get 50 out of 50. If I was fair.
Let's congratulate him, sir.
But I don't want him to repeat the same mistake in what? In the exam. He must go and get that mark in the exam. So, but if I give him marks because he understands what is happening, he won't learn. But now, obvious now he learned from his mistake. He cannot repeat that mistake again. Because I know the things that he didn't write there, he knew them. But what happened? He assumed that that information is not important. So please, guys, learn how to answer questions. Like now, you know, your script will be taken to external examiners. The script will be taken to external examiners. I cannot mark a script because it's I know what I know. You know these things. No, you have to write everything based on what, on the given problem. But let's meet in the afternoon. I deal with that the nested model part. From there, we'll give you the scope tomorrow after the practicals. We'll give you the scope for the exam after the practicals tomorrow. And also today, if we are lucky, we'll be able to release the what your marks. We'll release your marks hopefully today for you to confirm all your marks if they're captured correctly. So please, we will. I don't know how we. If we're going to share the Excel spreadsheet where everyone can go and check. No, not Excel. Wait spread sheet with all your marks. We can convert your marks to percentages. We'll indicate your test 1, test 2, quiz 1, quiz 2, quiz 3, quiz 4, quiz 5, and on how are we going to do the calculations. But we had an agreement that from my section, we'll take the best quiz. From my section. For those who wrote 2 quizzes, I'll take the best quiz. For those who said write 1, I'll take that one. Mr. Chavalala, he gave you how many quizzes? I think he gave you 3. He's also going to take his best. So you'll have a best quiz from Mr. Chavalala, and again a best quiz from my section. A best test from Mr. Chavalala, a best test from my side. The last one will be what? The assignment. So that's what we're going to do. Let me repeat. The best test from Mr. Chavalala, the best test from my section, the best quiz from Mr. Chavalala, the best quiz from my section, and the assignment. we will use that information to calculate your module mark. So whenever you give it the marks, we'll also give it the formula on how can you calculate your module mark. But make sure that even if you calculate it yourself, make sure that you check the official one that will be captured by the principal administrator. That one, I assume you'll see it from your online facilities. Make sure that you check the one that is calculated by what? By principal administrator. I thank you. Enjoy.